Okay, great. Can you guys hear me okay? About to start in a minute. Okay, great. Okay, I'm going to kick off. I'm looking at an ASUS 3G, 4G LTE Wi-Fi router. It's the model number is 4GAC68U. You can actually download this source code from the website, which is really quite good. Of course, it's based on GPL, so you're meant to do that anyway, but not many vendors actually tend to do that. So I have literally just downloaded this source code about 5 or 10 minutes ago. I had a 30-second look at the directory structure just to make sure that it was reasonable. So I think it's probably time to just have a look. I did notice there was some kernel code. So let's look at. It's not that. Don't know what CTF is. What is that? Let's have a look at source. Okay, so this is what I want to look at to start off with is this kernel driver. Let's have a look at that. Quite sure what that is. Okay, just straight off the bat, is there an IOCTL? Yes, there is. I'm not sure what. I like that that's static in uppercase. Interesting. Okay, so IOCTL. Okay, so it is actually checking for permissions. copy from user. Not quite sure why they've called it maybe they've just to stay. Copy. Nothing too much here. There's a lot of not a lot there. Here we go. EEPROM len. This is always there are potentially bugs here, but I think there's a wrapper layer that will block us. This is basically presumably to modify the firmware. So I don't want to get caught up on this because I did get caught up on this about a month or so ago, looking for bugs. eth command. So nothing too much here, nothing of interest. Copy to user. Let me just have a look at up here. Copy from user. Just thinking maybe there's an info leak. If it's copying any pointers back to this structure, but doesn't look to be any info leaks. So this isn't going to be a big bug because you need to be privileged anyway. I mean, it's size of e-data. Okay, so this is what we're sort of interested in here. I'm going to presume, oh okay, I'm just cautious about this because this is actually, there's upper layers guarding all of this. Release source RT. Oh, this is interesting. There's actually two. I would love a sign bug right now. No. Okay, so you can't make the offset or the length very large. Okay, if offset N3. So we're clearing out the little bits. You can't really do much with len because it's going to be less than 800. Is there anything we can do here to get sort of like an off by 1 or an off by a couple of bytes? there's nothing really there. Okay, do we have a bug here? Okay, so the question is anything so let's just check because a lot of this IOCTL stuff is restricted by an upper layer. So there is an integer overflow there if we can control offset and length, but I think from memory the upper layers of okay, let's just if they do their own IOCTL here instead of using the IOCTL stuff, you'd have to be annoyed. That's a big IOCTL. Yep. It looks like they don't use the IOCTL code from Linux. Okay, so I'm pretty sure this is a bug. Let's just copy it. It's not a big bug because you have to be privileged, but I mean, presumably it's, you might have a case of, and then we go to IOCTL. Yeah, it's even ifdef, so there's not even it's possible that it's okay, so was it C? So it's a bug. It's integer overflow. So you go down. It's it's a tiny bug. I certainly don't think it's not going to end the world here. But still a bug. Let's have a look at this. So no bug there. Bug here. Okay, classic integer overflow, bypassing bounds checking. Okay, so found a bug, but it's funny because in the other code they're a bit more sensitive, to be honest. Again, you have to be an admin, to do this, so it's not much of a bug here. If eregs, there's a chance for a sign bug. you guys want to ask me questions as we go, feel free. Copy to user. There's nothing too much here. Nothing much. What would be nice to get an info leak? So, anytime there's a pointer allocation, memory allocation. Nothing much. P stats. Here's a chance of an info leak. Where is P stats? No. Dereferences it, so nothing there. Nothing too much. E-test. What else do we have? Nothing there. Nothing. Okay, here's the main IOCTL. Okay, so copying nothing too much. Could be potential info leaks again. Size of args. Admin one. Copy from user. Out of memory. Copy from user. Yeah, sort of like odd sort of code. Not odd, but like, I mean, it's sort of fairly generic. Maybe they were using it for different OSs or something like that. So there's makes me think there might be bugs. buffer. I'm not sort of just too impressed with all this debug information. I mean, it's probably not terrible, but copy to user. Okay. So someone asked me what I was looking at. The code, looking at an ASUS 3G, 4G Wi-Fi router, and just looking at the device driver, all the kernel code supporting this particular device. IOCTLs are a good place to sort of start. What else do we have? Sort of looking for anything that manipulates a buffer or any integer values that are of use. Anything that says kmalloc is worth looking at. Yeah, it's quite interesting. It's odd, isn't it? That's odd. If I was better at kernel development, I'd have better idea of what this is for. It's certainly worth looking at. I'm not quite sure exactly what this IOCTL is doing. Is it doing a DMA mapping? Interesting. Definitely worth looking at. There's a K free. That's interesting. Okay, let's just have a quick look for kmalloc or any allocs. I like sprintfs. Well, what's going to be count? So writing something. How's it going to copy that back? Return len. presume PFS proc file system. Read proc. Yep. Now this is sort of interesting, I think. Yeah. This is sort of interesting. Maybe there's let me just have a look. I have found bugs in proc file system stuff before. Okay, let's just look at this one. Proc. Or is it read proc? I like the Docker. So what happens if n is less than page, like is n is small, and this read returns greater than n? So here we go. Copy to user n. Well, n bytes is greater than 0. Pos is greater than that. If n bytes, get free page. So this isn't, so let me have a look one more time. So the assumption here is count is less than what len will be. The question is, let's have a look. Is there any reference to count? No, it returns len. Now this isn't a bug. Well, it's a bug, but I think it might be useful for other types of, like if you chained it with something else, it could be useful. So the entire idea with this particular bug is that it will return, let's see what the return value on this is. Return start in red val. Yep, so, yep. It's an interesting bug. Again, it's not a usable bug at this point, but maybe if you use it in conjunction with something else. And I'll explain what this bug is. So, get the file name. Return len. Now this, I'll try to explain it. This is an interesting bug. When reading from the proc file system, we pass in a count to say the max number of bytes to be read. However, this code will ignore count. It's so crazy, it's such a crazy thing. It will ignore count and overwrite a buffer with something less than or 76 bytes range. So an application could have a buffer overflow if it tried reading from this proc file and their internal buffer was quite small. It seems so crazy. I don't even like. It can't be right. Oh, here we go. If n is greater than count. No, let's just check. No, okay, okay, so there is code here that does some checks. Let's just read this one more time. So if start equals null, so it gets, okay, start. It looks like there's all this code to check it. So we have page and we have start, end of file. Set start an address within the buffer, put the data at the requested offset at start, return the number of bytes the data place spare. If this number is greater than 0, so start should just equal page, am I right? It doesn't change start. Let's have a look. So start equals null. Okay, so it's actually null. So then we get down to here. If start equals null, killing me. N equals count. No. So we get blocked. N less than 0. Okay, there. Okay, so what else can we do? Pause. So can we manipulate the file pointer? If we make the file pointer point to past the end of the thing, we'll break out of that loop. And we'll free the page. So that's sort of weird. I mean, so you could maybe do seek to len plus x, no, seek to x, then it goes a len minus equals x, then if len is greater than count, len equals count. Okay, so if you seek to len plus len, read, file pointer equals plus padding, read, the file pointer will point to, file pointer say k, start equals len equals page, file pointer now at len plus padding, start equals page plus len plus padding, and n equals len. Okay, then we get out of that. Okay, so is this can't be right. Okay, so the question is, can you seek to the end, like, so the only thing that's blocking this now is, can we seek read proc file system? Is there a seek? Lseek max non-LFS. Okay, so what are we looking for? Max non-LFS. Max non-LFS. So we need to include. Okay, so it's really big. That's a big number. Now I think this is actually a bigger bug than what I'm thinking. Let's go through this one more time. So, okay, the bug in proc read proc FOPS is that read can return the value greater than the count arg. So that's the core bug, and so they've got all this code to sort of get around that. Now let's look at this. So on the first iteration, start equals null. Assume n is less than page size. If we combine that with the bug that you can seek to a file pointer beyond the end of what proc read proc would allow. So there are two bugs here. One, you have to be able to seek to beyond of the allowable file size, and two, read proc returns a count that is a return value that is greater than the count argument. Okay, so if n is, assume n is less than page size. Okay, so now we combine this with this thing here. So let's assume n is len plus padding, where len is return value of read proc. Now, no, assume ppos, where len, now n equals len plus padding. If assume n len plus padding is greater than count, now n equals count, and start equals page plus len plus padding. Okay. Then we get to this code. Okay, so buff, copy to user, copy buff, so start is going to be greater than page. So is going to be page plus len plus padding n equals count. What we want is len plus padding plus count is greater than 4096. Let's just go up to page again. Oh no, there's a blocker here. Oh damn it. Oh no, I was oh damn it. I thought I had it. Okay, so no, that's okay. It's totally okay. It's totally okay. N bytes is totally safe. It's only if it's really large that it's a problem. It's like checking for integer overflow basically. So that's fine. We want is len plus leading plus count. I think that's totally achievable. We get an info leak. Now, I know I'm just auditing this Wi-Fi router, but I think this bug is actually a bigger kernel bug. I think it's there's a case here in this proc read code. Okay, so now that let's just check. Read proc. Is it proc read or read proc? Read proc. Where is this code? Where was that? Okay, so this looks like it's okay. Okay, this is sort of interesting. Generic. Where is read? This is old code now. Proc read directory. Operations. Okay, so this looks like it's because it's using an old kernel version. No, it can't be right. Can't be right. Surely it would have something for proc read or read proc. Proc read link. Man, I'm out of touch with all this proc code. I have found bugs in proc before. Trust me to I'm looking for bugs in this bloody Wi-Fi router, and I end up finding some old Linux kernel proc bug. Are you guys still getting my what's going on here? I'm just checking that the stream is still going. Oh yes, it's still fine. That's still fine. It's just, I think it froze on my screen for a bit. So I might just, in another window, proc memory disclosure kernel 2.6, was it? Now, okay, I don't know. I'm not quite sure I want to keep on auditing. I found a couple of OK bugs, and I think this is actually like a kernel bug from this particular kernel version, 2.6.36. So ultimately the bug for this one is that you seek, where are we? So you seek to say len plus a random value, which is quite small, and then you read a count. Let's just have a look. Let's just have a look one more time. Was it read proc? If n equals 0, if start equals null, and start is set up here, isn't it? Yep. Proc block size could affect things. Let's look at proc block size. this could block things if it's really small. $3K. $3K. I think that's probably okay. Use some slack for overruns. I like that comment. So yeah, it doesn't really matter anyway, because ultimately it just ignores n bytes. So yeah, so it totally ignores n bytes anyway, so it doesn't really matter. So start equals null, n is greater than page size, that's fine, n minus pos, and then n goes to count and start move. So that's sort of the bug there, is like, what is the meaning of page plus pos if you're modifying count as well? Okay, I might stop it there. Again, this is a good bug. So the idea, of course, is that you need a buggy proc driver, basically, in some particular driver, and you're relying on sort of a buggy behavior in this Linux kernel version, which doesn't seem to be present, as far as I can see at a quick glance, in current kernel versions. And it requires two things on the driver. It requires that proc read, or read proc, ignores the count argument and returns its own value, which in this particular BCM driver it does. And it also requires that you can seek in this proc file to beyond what that count or length is of that file. And then if you seek to something like length plus padding, and then you read the file, you should get a kernel info leak, a memory disclosure. Great, so that's pretty good. And the earlier bug was just a sort of classic integer overflow with setting sort of writing this EEPROM, but you need to be admin anyway to trigger it. But classic integer overflow. Again, go to my Patreon or my Ko-fi, I don't know how to pronounce that, Ko-fi site for donations. Thank you very much, and I'll see you guys next time.